Here's an interesting example of using or calculating an NPV of a project, in this case a cost savings from buying a $10,000 machine as an annual cost savings of $3,000. However, in this case you have a choice of amortizing either the asset over a useful life of say 6 years or using what GAAP allows as an accelerated depreciation schedule. So if I were to amortize this over 6 years using a straight line, I would just amortize 1/6 of $10,000 a year. However, GAAP allows me to use a different schedule, an unequal front-loaded schedule where I actually allocate or depreciate a higher percent. So let's grab this spreadsheet and we'll just look at it and discuss it. All right, so here's the spreadsheet. The machine's going to cost $10,000 a year, savings of $3,000. You're going to sell it, however, at the end of the 5th year, even though it's a 6-year amortization. So you're going to decide kind of a surprise. You're going to sell it at the end of the 5th year. The tax rate is 40%, the discount rate is 12%. Now notice I'm going to use something called name ranges in the spreadsheet to make life easier. I'm going to call this cell right here savings. I'm going to call this cell K. This cell, if you go up here where normally you would see, say, you would normally say B2 here, I'm going to type in cost. And then I have salvage and tax. So when I use these names, I'll just put them out here so you remember what they are. Now, the reason I didn't use R here is R and C are not allowed to use as name ranges. Now the advantage of using a name range is anywhere else in that spreadsheet, actually anywhere in the workbook, I could say equals cost, and there's my 10,000. Or I can say equals K, and there's my 12%. So anywhere in the workbook, even outside of this worksheet, you can use these references. Now what you can't use is R and C, and you can't use cell references. Like I couldn't use K1, because if I try to use K1, it'll just refer to whoever's in cell K1. So I can't use any kind of cell references. So I can use K. So here's my depreciation schedule, accelerated. It says I can depreciate 20% of the cost of the asset, 20% of the cost in the first year. That's 2,000, 32% and so on. So I'm going to amortize the full 10,000 over 6 years. Now I want to calculate something else called a depreciation tax shield. Remember from the last example I said, even though depreciation is not a real expense, it does create a real tax consequence, which is a cash flow impact. So depreciation is not an expense. The only actual cash expense, is not a cash expense. The only cash expenses happens when you buy it. But the depreciation, these depreciations are going to save you taxes. And specifically, if you multiply the depreciation amount times the tax rate, that is the actual savings in taxes. So I will save $800 in year 1 because I was able to depreciate 2,000. Now if I did a straight line, I would depreciate this asset over 6 years. If I multiply each year times the tax rate, I will save $666 per year in taxes. So no matter how I amortize the full value of this asset, $10,000, I will save $4,000 in taxes. But the accelerated method allows me to recognize it faster. And we learned from the last topic, time value of money is nearer term cash flows are more valuable than farther term cash flows. So this is going to have a higher present value than this. Now if I go down a little farther, I said this, we're making a more interesting example. You set up a 6-year amortization, but then you sell it in year 5. So we're going to sell it at $4,000 at year 5. That's my residual. I think I set up a salvage. I called it salvage in this case. Looks like it has the name range of salvage. So in this case, I could just type in equals salvage. And then I'm going to calculate the impact or the net cash flow in that year 5 when I end this cash flow, or I sell the asset. So first, I'm going to sell the asset for $4,000. Doesn't matter what method I use, accelerated or straight line. I'm going to get $4,000. Now the book value of the asset is going to be the cost, 10,000, minus the accumulated depreciation in the first 5 years. We're going to assume we sell this at the end of the 5th year. So I would take 10,000 minus the accumulated depreciation using acres. It has a book value of 576. If I use a straight line, it just didn't amortize this last year, as a book value of 1667. Therefore, the taxable gain, what I get taxed on, is the difference between the salvage and the book. So my taxes are just going to be the tax rate times the salvage minus book. So the after-tax cash flow from the sale of the equipment is going to be 2630 and 3067, depending on what method. Now let's go ahead and calculate the free cash flows and NPV of this project. I'm going to spend $10,000 no matter what I do, no matter how I amortize it. That'll be spent today. Now I'm going to use a different way of calculating the after-tax cash flows, and it's a common way, so I just want to expose you to it. The normal way, we just did it in the last couple problems, is I just calculate after-tax net income using depreciation. So there's my net income, or net profit after tax. I then add back the depreciation and subtract CapEx. That will give me a cash flow. And if there's no CapEx, really, I'm just taking my after-tax cash flow and adding back depreciation. Now I could rearrange terms here. I could actually, this is the exact same thing algebraically as taking the after-tax income, assuming no depreciation at all, and then adding just the cash impact of depreciation. And if we take the depreciation expense times the tax rate, that is called the Depreciation Tax Shield. That is actually the cash flow savings from the depreciation. So instead of having it here and reducing the taxes, then adding it back, I could just add that impact of the reduced taxes by multiplying times the depreciation times taxes. So that's what I did in my spreadsheet. Here's my after-tax savings. That's my $3,000. And I could have used the word savings there. Times the 1 minus the tax rate. And here I could do the same thing. Savings times 1 minus the tax rate. Now it's pretending that there's no tax savings. No depreciation. And then I'm going to add just the depreciation tax savings, and I've calculated that up here. If I take the tax rate times the depreciation for the acres, these are the tax savings. I'm going to save $4,000 in taxes, and I'll save $4,000 in taxes with straight line, but they're going to happen earlier with acres. So the cash flows are going to be front loaded. So even though we had the same cash flows, the total cash flows are $5,400. Notice I also had to add the after-tax residual here in the last year. The cash flows are exactly the same. However, these are front-loaded because of acres, the accelerated method. Therefore, when I calculate the NPV, this one gives me a higher IRR and a higher NPV. So this shows the importance of depreciation, which isn't a real expense as far as cash flows goes, but does create a real cash flow impact because of the tax savings. And anytime you get to accelerate of depreciation, you should. It's going to save you, or it's going to increase the value of the project. The cash flows are going to get nearer in time. Now, last thing I want to do in this topic is talk about user-defined functions. So this is not related to anything else we've done so far. And we're going to use these tools later in the course. So when we use Excel's built-in functions like PV, NPV, IR, FV, sum, and so on, average, these are called built-in functions. But we can create our own functions. Say we want to create a function for the present value growth perpetuity, which is just the present value of a perpetuity that is constant. So it's really just, the formula is just the cash flow received in 1 year divided by the discount rate K minus G. Now we can create our own function in Excel. So I'm going to go to Excel. And where these things are done is if we can go to the developer tab. Let me show you how I get the developer tab. File, Options, Customize ribbon, make sure Developer is clicked right there. Selected it, and I'll hit OK. So if I go to Developer, Visual Basic. Visual Basic for applications is the programming language that Microsoft Office uses. This is called the Project Explorer. If your screen doesn't look like that, hit View, Project Explorer. And then what we're going to do is we're going to, at one time in each worksheet, just one time, we're going to hit Insert Module. Don't do it again. Now it says Module 1. Here's my spreadsheet called Book 1. And I can write programs in here. Now here's what programs look like in VBA. Now actually there's a shortcut key, by the way. I can actually close this right here. It goes back to the spreadsheet. If I just hit Alt F11, I wind up here. I can then go to Module 1. Now in the modules where you're going to write programs. Now programs, right, here's what it looks like, Module 1. Programs have a certain syntax you have to follow. The programs are actually called functions. So you write the word function. You give the function a name, any name you want. And then in brackets here, you then put the inputs or the parameters. So to calculate the present value growth perpetuity, I'll just name it PVGP. And I need the cash flow in year 1, I need the discount rate K, and I need the G. I'll then use some single quotes to maybe add some comment lines. In VBA, if you do a single quote, everything gets ignored to the right. And then, so this says PVGP computes the present value of a constant growth perpetuity. Cash flow 1 is the first cash flow in year 1. K is the discount rate, and so on. So these actually don't have an effect. You don't even have to put them in there, but it's nice to document programs. And then all you need to do is take that program name, PVGP, and just put a formula. PVGP is equal to cash flow 1 divided by K minus G. Now, end function will automatically come up when you hit enter. That tells it the function is over. So I'm going to go back to my Excel. All right, make sure you go Excel, because if you go Alt F11 from PowerPoint, you will also wind up in the VBA section of PowerPoint, but you won't be able to execute those programs in Excel. So I'll go to Excel. I'll just open up a new worksheet. It doesn't matter. And say I want a cash flow of 100, a discount rate of 10%, and a discount growth rate of 3%. Those are my parameters. And I want to calculate the present value growth perpetuity. Now I would just take 100 divided by K minus G. So that's worth $1,428. Now I can create a program in VBA, right where all these other programs are, by going, I'm going to go Alt F11, go to my module, I'm going to type the word function, PVGP. That's the name of the function. I'm then going to put the parameters, cash flow 1, K, comma, G, and hit enter. Notice how the word function turned blue? That means it's a reserved word. That's a special word in VBA. Can't have a function called function. Can't have a variable name called function. And it also created the end of my program for me, end function. So end and function are both reserved words. I couldn't have a variable name function or a program name function. I could do a single quote and say this program computes the present value of constant growth perpetuity. I can put as many of these as I want, and I can put the program, actually the actual formula. PVGP equals cash flow 1 divided by K minus G. So I actually put in the code there. I could actually put this comment over here if I want it. I'll just show you that. Anytime you put a single quote in VBA, everything to the right is ignored and it turns green. In other words, you didn't really need it. It's just for helping people understand the program. So this is a function or a program. Here's the name of this function we're going to write. These are the parameters, the inputs. This is the formula. So now and this is in Module 1, Book 1, so I can verify that looks like my spreadsheet. That's the name of my spreadsheet. Module 1, Module 1. You have to be careful that you don't write programs in these other areas because it will not work. It has to be in Module 1 or a module. You cannot also have a program if you made a mistake and say you inserted another module. Now you have Module 1 and Module 2. That's okay, but I can't have that program in both modules, otherwise it won't know which one to execute. So I'm going to now close this, and I'm going to insert the function here by going to a blank space here, click on the function, insert functions. Now these are the built-in functions. I'm going to go user-defined functions, and there it is, PVGP. Now I can input it just like I input all my functions. Cash flow, K, G. All right, so now I've built my own program, my own function in Excel. A couple things you need to know about functions. One, when I go to save this file, I'll just put it to my desktop. You have to save it as a macro-enabled workbook. If you do not save it as a macro-enabled workbook, you will lose all your modules, all the programs you've been working on. So I would make that default for this semester. Whenever I have a worksheet, workbook, I'm going to save it as a macro-enabled workbook. If not, I just deleted all my functions. Two is this function, I'll hit Alt F11 again, is only tied to this workbook. So I can't open up another workbook and use it. What I could do is come in here and copy it and use it in my new workbook. All right, so that is the basics of doing a program. You insert a module in the VBA area here, type in the word function, and function shows up, give it a name, make some calculations. All right, so in this topic, we applied NPV and IRR techniques to evaluate projects. We computed net income, straight line and accelerated depreciation, depreciation tax shields, after-tax salvage values, and free cash flows. We built data tables to perform two-factor sensitivity analysis, use name ranges in Excel, and created user-defined functions. In your assignment, you'll do some NPVs. You'll write a program called after-tax or salvage after-tax. And you're going to do a mini case, which is this 2-page case from the book. You don't have to worry about these parts of the problem. And here's the worksheet you're going to fill in to calculate the value, the IRR, of this condo example. All right, that's it.